Hey guys, so welcome to my new video. So in this video, we will understand what is a machine learning process and we will see what are the different stages involved in it. So nowadays, a person who is very new to machine learning field and has been working in a different field, right? For example, let's say software development he has been working on, and he doesn't know about machine learning, right? So he has a misconception that machine learning is mainly this process. This is model training, I mean. Okay, so this is the model training process that they think is a machine learning process, where we just create a model and train a model and that's all, right? So no, a machine learning process involves various stages. That is data collection, data cleansing, data splitting, model training, model evaluation, model deployment. These are all the stages that combined becomes the machine learning process, right? And it's not like a single person is working on all these stages. So basically, a machine learning developer will work on this model training part, right? And the data analyst will work on this data cleansing part, and the data engineer will work on adding the data from the database, collecting data from the database, scraping the data, okay, and engineering the data basically. That is why we call him a data engineer, right? So he will work on this data collection part, right? So a data analyst has a job of analyzing the data, exploring the data, right? So that is why he works on this data cleansing, where it involves analyzing the data, visualizing data, and creating the dashboard out of it, right? So let's take it from the start. So the first stage that comes in a machine learning process is data collection. So in data collection, let's say you wanted to have some data about a let's say animals, right? So what are the extinct animals? What are the current animal ranges? What are the number of animals that are present in a particular state or a region, right? So what you will do is you will go to a, let's say, a discovery website for an animal, let's say, and or you can say a government report for animals, and there you will scrape all the data out of it, and then you will then when you will bring it into a particular CSV format, and then you will store it in a particular database or a cloud or a for CSV, for example. So this process basically where you are scraping the data, collecting the data, and then storing it into a database or a CSV format, right? So this is basically comes in this category of data collection. Then comes the category of data cleansing. So in data cleansing, now the data that you collected from the particular website or from a different source like Kaggle, right? Kaggle is one of the source where you can take a data set for your exam, for your like practice or for your personal project. You can take a data from Kaggle also, right? So the data that is available there, it would have null data out of it. Like it would have a noise. So noise is something that generally is present on the data set because the data is not clean, right? So by noise I mean let's take an example of age. So you did a survey, you went to like you created a form and you circulated that form into your friends, and your friends have added everything and some of your friends have not added their age in the form. Right? Now what you will have a null value for that age for that particular friend, right? Now, if you provide that null value to the model, it will incorrectly train or the accuracy might not be high. If the accuracy is high, then it will not provide you the correct information when you will provide the test data, right? So the test accuracy will be quite low, right? So that is why we do data cleansing. In data cleansing, the first thing what we do is we explore our data. We try to understand the data, what insightful information is present in our data, what all data we need to clean, what type of distribution it is, whether it is a Gaussian distribution or not, right? So we do all these things that comes under the category of exploratory data analysis. So a data analyst, what he will do is he will try to analyze the data, plot a dashboard out of it, and plot various plots out of it to understand what all informations are present in your data. Then comes the stage of data pre-processing. So this stage is basically inside the data cleansing only. So in data pre-processing, what you try to do is you try to bring stability to your data so that when you train your data on a particular algorithm, so the accuracy, the model algorithm is basically stable, right? So accuracy, if you change something in your data set, or if you add any data, so your data is not get the model accuracy is not getting changed basically, right? So it should not be like when you have training data, it is given 90% accuracy, but when you calculate the test accuracy, it is just 50 or 40%. It should not be like that, right? So what we do is we perform data pre-processing. What is data pre-processing? So I gave you an example of age. So age, you have the null value. So in pre-processing, what you try to do is you will fill up this null value. So there are different methods to fill up this null value. You can take a median of all the ages, or you can take a mean of all the ages and then fill up all the null values with that age, right? So this is one of the way. Then comes the data normalization and standardization. So data normalization and standardization are the categories involved in data preprocessing. So basically, there are few models where standardization is important. So standardization and normalizations are basically used to rescale your values. Let's take an example for standardization. So let's say you have a height and a weight column, right? So weight can be in the range of, let's say, 40 to 100, but height is in centimeter. So it will be around 100 to 180 or 190 centimeter, right? So the when you will train your model, so this difference between the values, right? So this is range from 40 to 100, and then it is from 120 to 100 to 190, right? So to scale it, what we do is we standardize our values. So models like SVM, that is support vector machine. So we'll see in future videos what a support vector machine model is. So basically we need to standardize that value. If you won't do that, so the accuracy won't be that high, right? So that is why we need to standardize a value and rescale it to a particular range, right? Similar thing is for normalization. So if you wanted to bring our values to a range of 0 to 1, we use data normalization. For example, let's say age. We wanted to bring our age column to a value of 0 to 1. So what we can do? We can use a normalization formula. For example, for a particular age, a normalization formula can be a value minus minimum value of those age upon maximum minus minimum value of that age. So if you divide this value, you will get a value between a range of 0 to 1, right? So this can be one of the method to do a data normalization. So data normalization is basically performed in models like k-nearest neighbors or neural networks. So neural networks are the important concept where normalization is mostly used, because there we have to bring the values to a particular range of 0 to 1. But most of the times we have to do that, right? Then comes the category of data splitting. So now let's say we have 1 lakh of rows, right? Generally we have more rows also, but I'm just taking example of 1 lakh rows. So what you will do, you will split this data of 1 lakh rows into 70-30 ratio or 80-20 ratio. Okay, for 80 for training, 20 for testing, or 70 for training and 30 for testing, right? So this stage of splitting your data into two, that is training data and testing data, is called data splitting. Why do we do that? So that we have a same type of data set that we have performed cleansing, so that we can perform a model evaluation also, right? Firstly, we can train our data on that 70% data set, and then we can predict the values of that 30% data set, right? That is testing. We can evaluate a model on that 30% data set. So this is model evaluation that comes in. So in data splitting, what we do is we also shuffle our data set. So shuffling techniques are there. So what we do is we shuffle our data set so that there's no common values. For example, let's say 1, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. The first 10 rows have similar values. So if you train a model on those first 10 rows, so you try to get the same information, right? So model will think, okay, so these are the most available information. So I will try to see that whenever I have to give score for a whenever I will have to evaluate on the testing data, I will try to give this information only because these rows are mostly present. right? So this is wrong. That is why we shuffle our data set so that whenever the model is trained, it will have different type of information and not the similar ones, right? Then comes the model training part. Model training part is where we try to we have analyzed the data already, but now we try to differentiate into a different categories, like which type of model it will be required. Supervised model training is there, or unsupervised model training is there, or reinforcement, right? So a supervised is where you already know the input and output in a data set, right? For example, we wanted to predict the age, right? Male and female, and we have some different values, right? For example, we have the information about the structure of a body, and we have to predict whether the person is male or female, right? So for few values, it will be 0 and 1, 0 for male and 1 for female. And then we have to predict the value for other values, right? For example, we have to predict few like 30% data set we have divided, right? For that, we have to predict the value, right? So this is comes in supervised learning because we already in the training data set that we have provided, we already knew the output, right? That for this person it was 0 and this for this person it was 1, that is female. And then comes a classification. What is classification? Classification means that we have to categorize the values. For example, the values that are given belongs to a dog category and these values given belong to a cat category. So we are classifying the values, right? If this belongs to this category, this belongs to this category. So this is called classification. So supervised learning, basically we have two types of technique, regression and classification. In model training, of unsupervised learning type, we have two categories. One is clustering and one is dimensional reduction. In clustering technique, we have a model called K-means clustering, and then we have DB-scan. So these all models you will see in future videos. What all, why are these models used, and what are the importance of these models, and when we should use these types of models, right? Then we have a different category of model training that is called reinforcement learning. In reinforcement learning, basically, we have types of training called policy or reward training. So, in policy means that whenever we are trying to train a model, we see we try to calculate, do some error analysis. For example, we try to calculate some error. On the basis of that error, we try to again train a model until the error is significantly reduced, right? So this is basically the reinforcement learning. So reinforcement learning examples are autonomous cars, video games, right? So these games, video games or autonomous car, basically they have trained their models by using reinforcement learning, right? Once a model is created, trained, right? There are different stages that are inside that also, right? We calculate the accuracy out of it, and then we do a model evaluation. In the model evaluation, what we do is you remember that we have split the data into two, that is training and testing. Testing was 30%. So now what we will do is we will try to predict the output for that 30% data set, and then we will try to create the accuracy. If it is the classification, right? If it is the classification category, that is supervised learning, we would already know the output of that, right? So we can generally calculate the test accuracy easily in there, right? Predict minus the actual value that came, right? So from that, the model evaluation is done. Here we try to calculate the accuracy of a model that we have trained. And then if the accuracy is less, we will try to retune a model and we'll again train a model, right? So this model training and model evaluation are in a cycle they are performed, right? And then once that particular accuracy has been reached that we wanted to achieve, we deploy a model. For example, we create a particular front end and back end and we use that deployed model to predict some output. We create a particular UI out of it and then we use that model, right? Model deployment can be done anywhere. You can deploy it on AWS also, right? Where you can use that instance of that AWS and use in your UI also directly, right? Because model deployment file is very quite huge. So you directly use in your backend. You have to store it somewhere and then you can use it from there, right? So we deploy a model there. So this is basically the machine learning process. Just an overview out of it, but these are the stages involved in a machine learning process.